Hello guys, let's see how we can install WordPress and run it inside of Docker container. So basically we'll be creating configurations and then we'll be loading them up with Docker Compose. The first thing we would like to do is to create an environment file. Just open your favorite editor. I've chosen Visual Studio Code and we save this file as .env. Here we'll place basically our credentials with which we would like to authenticate inside of the MySQL server and inside of WordPress. And the first one will be MySQL root password. And let's say that it will be MySQL root. Then we'll create our user. So it will be MySQL user. Let's say WordPress user. And the MySQL password, it's WordPress password. After creating our environment file, we will actually create the Docker Compose file. So here we save it as a docker-compose.yml file. Inside, we will start by specifying which kind of version we would like our container to use. And now we'll actually create our services. We will create 3 containers. One will be for our database, where we'll be using MySQL. One will be for the WordPress and one for the PHPMyAdmin services. Here for the DB, it will be the name of our service. For the image, we will specify that we would like to grab the latest MySQL image. Actually, when we go to our browser, we can go to hub.docker.com, and if we type MySQL, we see that we have officially supported image of MySQL. If we go to tags, we can browse the latest one from MySQL. So that's what we are doing here in the code. We are pulling this image from the Docker Hub repository and it's automatically configured for us. Nevertheless, we have to specify environment variables. So we'll specify our environment file by typing env file and we'll type .env, which is the name of the file. Inside of the Docker container with the name of DB, we'll provide additional environmental variables which are not so sensitive, such as the MySQL database. So we'll just type environment and here we'll provide MySQL database and let's say it will be WordPress. The next thing is the volumes that we'd like to specify. We'll provide one volume and we'll call it dbData and we'll make it to point to var lib MySQL. We'll be having one volume which Docker will create and everything that MySQL installs inside of this var lib MySQL directory will be saved inside of this newly created volume. This means that when we restart the container, all the data will be read directly from this persistent volume and our data will remain the same as before. So we are here just defining the volume. Afterwards, we'll create it. One more thing, it's a little bit of a patch. We'll run a command and it will be a default authentication plugin equal to MySQL native password. In this way, MySQL will accept username and password as authentication and our service will run normally. Okay, with the DB, we're ready. Now we'll set up another service, which we'll call WordPress. As you can see, the indentation, WordPress should fall directly below DB. Okay, for the WordPress, we will specify that we would like, before starting the WordPress, this container DB to be started. Or in other words, we will say that the WordPress container depends on the creation of the DB container. So we'll type depends and here we'll provide the DB container. Next is the image we would like to grab and pull from the repository. So I will grab the WordPress latest. So type image, WordPress latest. And for the environment, we'll set up several variables, but let's not forget to include also our environmental file in order to be able to read it. Okay, for the environment, we'll set up the connection to our database container. So type WordPress db host equals to db, and the db is the name, as you know already, of this previous service. So Docker will set up everything for us, like the connections and ports. The next thing is to provide the username and the password to be able to log in inside of the WordPress. So we'll type WordPress db user. We'll grab it here from the environment. We'll use this variable, MySQL user. We have to place $1 sign since we are referencing external variables. Okay, now we'll do the same for the password. WordPress db password equals to MySQL password, and we'll specify the WordPress DB name where our records will be stored and our posts, and it will be just WordPress. Okay, now it's time to set up the volumes, almost the same way as before. We'll create one volume with the name of WordPress. We'll access var HTML directory inside of the container. One more thing to notice that this WordPress container actually has inside integrated web server. So in order to browse directly the information within the WordPress, we need to expose some ports. Otherwise, the container will stay enclosed and it will work, but we will not be able to access the web server from outside of the container. So that's why we'll specify for ports such settings. This means that for our local port 80 will be redirected to the internal port 80 of the container, and whatever is running on this port, such as the WordPress installation, we'll be able to see it by browsing localhost with the port 80. So that's for the port forwarding, and this is actually the setup of WordPress. Now we'll set up another service. This will be our PHPMyAdmin. We'll again start with depends on DB. Okay, and now for the image, we'll grab the PHPMyAdmin latest. Again, the environmental file and some environmental variables. This time it will be the connection with the database, which PHPMyAdmin requires to be set up as a PMA host, and we'll be referencing the database container or database service here. Okay, the next thing is the password for the root account of the MySQL in order to enter as a root inside of the PHPMyAdmin. This is for the setup of the PHPMyAdmin. So we'll type MySQL root password and we'll grab this MySQL root password here. Okay, and we'll expose also ports. This time we would like port 80 on which PHPMyAdmin will run to be exposed externally as a port 3333, and it's for the configuration of our services. And one last thing we need now for all those volumes that we created, WordPress and DB data, just because they are for now just links to information inside of the containers, we need to recreate them. We'll just watch very carefully the indentation. It has to be below services, and here we'll type volumes, and the first one will be WordPress and the next one will be DB data. Okay, that's the file we save. We have the environmental file, and we go to our terminal and we can type docker-compose up, and as you can see, first we're creating networks between the containers so they can exchange data, and we're starting with MySQL. It's pulling different layers or parts of its image directly from the repository, and it will be saved later in our machine. Now it's time for the WordPress installation. We're seeing that we're downloading different parts from the image containing different files, and later they'll be extracted. Now it's time for the PHPMyAdmin, and now we see the process of creation of containers. First we are creating the database container, then the PHPMyAdmin and the WordPress container, and afterwards we see that first PHPMyAdmin is checking inside of the container whether it exists, and since we don't have previous installation inside, it's copying its information from the image inside of this directory. At the same time, we see the other container, db1, is initializing the initial MySQL database, and the same is happening with the WordPress. It's copying its contents inside of HTML. All right, the WordPress has been successfully copied, and we see several messages, connection refused. This is because WordPress is trying to connect very early on our database, and the database is not quite yet ready, so you shouldn't be afraid about this. Afterwards, we see that the MySQL initialization process is taking place. MySQL is listening actually on this port at 3306. Now we can go to our browser. Here we can browse first, let's say, the WordPress installation. We see that we are inside of the container, and we can choose our language. We can click continue, choose username and password, choose an email, and we can proceed into installing WordPress. At the same time, you can see here the information that our web server is telling to us, all the connections we're having right now and everything else. You can debug. Okay, we don't want to change the password. It's just test installation. So very soon we will be having ready installation. Okay, we can log in into our WordPress, and as you can see, this is our fully functional WordPress inside of the container. That's how the front end looks like. You can start using it without any problems. Now for the PHPMyAdmin, if you remember from the configuration, we need to use a port, different one, in order to load it up. Okay, so with username root, and for the password, if you remember, we provided MySQL root password here in our PHPMyAdmin service from the environmental file. So we grab this password MySQL root and provide it here, MySQL root. Click on go, and we're inside of PHPMyAdmin, and here we can see the WordPress database. We can import information and do whatever we like to. So basically that's how you do an installation of WordPress inside of a Docker container. Now we'll see how we can create one Express application in Node environment and transfer it into a Docker container. So for this, we'll create our initial folder of the application. It will be Node in Docker. We'll go inside and we'll launch Visual Studio Code. All right, from here, we'll create a new file. This will be our application. So let's save it app.js. And inside, we'll require the Express library. Afterwards, we'll make an instance of the Express application. And now we'll create our first route. So the moment we are reaching to the route address of our website, we would like to process these requests and to invoke the following response to the users. So it will be just response and hello from Express app. The next thing is to choose a port. We'll set up port. It's either will be set from the environment, so it will be process environment port, or we'll use a hard-coded 8080 port for running our application. And then we'll make the application to listen to this port. And when application is ready to process requests, so we'll just console log application is listening, and we can specify even the port here. Okay, so that's our application. We can save it. We'll open the terminal, and here we can type just node.js. And if everything is okay, we will receive app is listening on specified port. Just a second, we have to specify here string literals in order for this to be interpreted, and run again the code. We see our code is running and the application is listening. If we open up a browser, we open 8080, we see that this is hello from the Express application. Right. The next thing is to create the package for this application. We'll just type npm init. We'll specify the package name Node in Docker and the version. For the description, we'll write that this is our Node Express app in Docker. The entry point will be app.js, and we'll specify the author. Pretty much that's it. This is our package JSON. So far, we have no dependencies listed here, and we'll add them one by one. So let's add the first dependency. Here we'll install Express for processing our requests, and also Node monitor in order to restart the application every time we are making changes to the server code. So we don't need to stop and restart the server by ourselves. We'll do this with npm install savedev. This will put them into our development dependencies, those packages, and Express and nodemon. And here we see the dependencies appeared under the dev dependency section in our package.json. Now I will configure a little bit the application. So far we'll be starting the application with Node and then app.js. Now we'll change this. So for the scripts, instead of test, we'll type here start, and we would like to run the following command, node app.js. If we save and run npm start, we'll see that our application will be started via npm. Okay, we can test this in our browser. If we refresh, we see the same output here. Okay, once this is set up, we'll create our Dockerfile. So inside of the same directory, we'll type Dockerfile. We'll start by using Node.js Alpine version. So from Node 10.16 Alpine, and then we'll create one directory inside of the container. It will be called Node app. We'll change inside of this directory. Okay, once we are inside of the container and inside of this Node app directory, the next thing is to install npm and Node monitor, the latest versions of those. This is because we would like to keep them updated. And here for the Node, we're using a specific version because this is the version we have tested our application and we know that it's working. And if we have used the latest version, it might introduce some breaking changes. The next thing is to copy the package JSON and package log file from our local directory. Actually, this file here, package JSON, to the container. So we'll do this by using the copy package JSON and package log JSON inside of our container node app directory. And now we'll run npm install. So it will grab all the information inside of here, looking for those dependencies, and we'll install them inside of the container directory. So type run npm install and no optional. This will not include optional dependencies, which we don't need inside of our packages. And also we'll clean the cache of npm. And when our package is installed, we are ready to copy its bundle inside of our Node application. So we'll just type copy everything inside of our Node app. Now we'll expose the port 80 and we'll run our application. So we use node app.js, this command. And that's pretty much our Docker file. We're using a predefined node image. We're creating one directory, installing our needed packages, npm and node monitor. And then from our local directory, we're copying the following files inside of our container, running the installation of all the packages needed for our application. Then we're cleaning up the cache of the installation. And after we have everything installed, we are just copying it inside of the container directory node app. We're exposing the 80 port and we are running our application. Actually, we don't need to expose ports here. We'll transfer this to our Docker Compose file. And that's the configuration for now. Now let's create our Docker Compose YAML file. We'll save it as Docker Compose YAML. And here we'll specify version of the Docker Compose we'd like to use. We'll use this because it's for development. Version 3 is more for production. We'll specify our services. I will have just one service. We'll be calling it Express. And then we'll specify where we would like our build to be placed. So the context of our build. So we'll type build. It will be inside of the current directory. So this will specify that we'll be referencing files inside of our Node in Docker application, local one. The next thing we would like to do is to run our Node monitor. So we'll run it with nodemon app.js. Just because afterwards we would like to debug this application, we'll place this inspect option, and on our address 0000, we'll open up 5858 port, and this will make sure that once we make changes to app.js file, it will restart our Express and Node server, and also we'll be able to debug this in Visual Studio Code. Now for the volumes, we would like to provide access to the current directory from the Docker. So this is our current directory we reside on, Node in the Docker directory, and we will map its contents to Node app inside of Docker. So we'll be copying the files from the local directory to the Docker volume. And also we would like to review our Node modules to be visible inside of the Docker container. So we'll type node app, node modules. Afterwards, we'll specify the ports we would like to open. And so for our application, we'll open port 3000 from outside, and it will map port 8080 on which we were running our app.js. If you can remember, we were opening port 8080 and we were mapping it to be visible outside port 3000. The next port is for debugging. It will be 5858. The same port will be opening from the container. That's pretty much for the Docker Compose. We would like to create another file, which will be dockerignore, and we'll specify inside which files we would like not to be transferred to the container. This will be our Docker file, Docker Compose, and also our Node modules. Everything inside of this directory we don't want to be existing in our container. Okay, once we set up everything, let's run our current configuration, Docker Compose up. We see that we have certain error. We go here, so we need to indent the code a little bit. Okay, we save again. will run. So first we see that we are downloading the Alpine image and we are extracting the files. Then we're creating this directory node app, and inside of the container now we are installing the latest version of npm. npm is installed. Now we're doing the installation of Node monitor. It is installed. We're copying the files. We're cleaning our cache, and beforehand we're installing all the projects inside of our package.json. We are copying our bundle, creating our image, and now we will see that Node pointer is starting our server with the debug option, and we see that the application is listening on this port, but actually we are forwarding this port to port 3000. Let's open up our browser, and here on 8080 we don't have anything listening, but let's see inside of the container, and we see we have successfully placed our application inside of the container. If we go to the terminal, if we type docker-ps, we see that we have one image created, Node in Dockerpress, and we have the port forwarding working. Port 8080 is redirected to port 3000, and we have port for debugging. Let's set up our debugging right now. So we need Visual Studio Code. Okay, we are inside of our project. Let's open our debuggers. We can add a configuration for Node.js. We can add our remote root. This will be the directory inside of the Docker. It is called Node app. And we are provided with a launch JSON file, which we will have to configure now. As we have remote root, we'll add local root. So this will help to connect our local files with the Docker. For here, we'll provide our workspace directory. The port will be the port for debugging. We specify it, which is open already. We would like to be able to restart the debugger. So restart true. All right, let's set one variable, and also we'll change the message to hello from the Express app in Docker. We save the file, and when we go to the terminal, we see that all the time we are saving, a Node monitor is restarting our server to reflect our changes. This means that when we go to the browser and again browse our Dockerized application, we see that changes directly are reflecting the rendered view. And if we run the debugger, click on refresh here, we should be able to see the value of this constant we set here inside of our debugging variables. We disconnect from the debugger, and you saw how easy it is to set up debugging inside of the container of a Node application. All right, guys, let's see this time how we can turn one Angular application to run inside of a Docker container. So for this, first we'll create our Angular project. We'll just type ng new Angular in Docker, and this will scaffold our application inside of the following Angular in Docker directory. We don't like to use Angular routing for now. It will be a single application. Very soon the application files will be installed together with their corresponding modules. All right, we see that Angular has initialized Git repository for the project, and if we type ng serve, first we'll enter into the project directory, Angular in Docker, and now ng serve. This will start compiling our TypeScript files and creating a bundle, so we can start the compiled version of the project inside of this address localhost port 4200. Let's use this port and host, and that's our Angular application. It's running correctly. So this is the first step to install locally one Angular application. Now we'll transfer it to run inside of a container. So again, we go back to our command prompt. We'll stop the application and we'll start Visual Studio Code inside of this directory. We'll create a new file, which will be called Dockerfile. I will start setting up the project. First, we'll use a base image from Node.js. So we'll type from Node, and we'll use this version, which is current right now. Then we'll set up our working directory for dir, and then app will be the directory where we'll have our application residing in the container. So we'll copy package.json from the local directory inside of the container app directory. This will optimize our image, so we will not disturb the cache if packages are not being changed inside of this package.json. So we'll have it already built. Then we'll run npm install, and we'll install the Angular CLI. Again, we'll have them in one line to create just one layer inside of Docker. So run npm install and npm install global Angular CLI. When npm has installed everything from our package.json, which is actually residing on our local directory, and then installed on top the Angular framework, we have our application already bundled, so we can copy the resulting files into the container. So type copy everything from our current directory into the app directory of the container. And the last thing is to start the ngserve command, which will create a memory server. So type ngserve and we'll give the localhost address. So that's for the Dockerfile. So let's recap. We are using a base node server image. We are creating one directory app where we'll be copying for caching reasons our package.json from the local to the container directory. Then we'll be installing our dependencies as well as the Angular CLI. And when everything is ready, the resulting files will be copied into the app directory of the container. And the last thing we're doing is that we're running ngserve to serve up our application inside of the container. Okay, we save this Docker file, we create docker-compose.yml file, and here we'll create our service which will run our container. So first we'll use development version 2.3, and then we'll list the following services. We'll have service called Angular, and here aside for the build, we will use the context of the current directory. Since we are developing the files inside of this current directory Angular in Docker, we're setting our context to be here, so Docker can use this directory to build up our image. Okay, we set up our context, and then we'll use the current Docker file. So type Dockerfile. We'll be passing this file for the building of our image. Then we'll specify our volumes. We'll have two volumes. The first one will be of our current application. So we will be mapping our current directory, this Angular in Docker, to the directory app inside of the container. So the moment we are running our container, all those files will be accessible inside of the app directory of the container. They'll be copied there. And then we'll create another volume. And this will be for exposing our app node modules. And this is actually anonymous volume, which means that we would like to preserve the content of the container's directory node modules. So adding of new modules not to reflect the node modules inside of the container. The last thing is to expose the ports towards which we would like to connect to our Angular application. We use the same ports, 4200 will be mapping inside and outside of the container. So this will be the port inside of the container, which will be redirected to the same port outside, viewable for us. And that's for the Docker Compose. So we created one service, which is called Angular. We set the context to our current directory. We're using the Dockerfile, which we previously created, and we set up two volumes. One is for our applications, so like all of our working files here in this Angular in Docker local directory to be copied when this container is created. And the next is we would like to preserve the node modules inside of the container to be protected from changes whenever we start to change contents of our local directory node modules. Then we are exposing the following ports. Now, before running Docker Compose to start up our container, we'll create a new file, which is dockerignore. And inside, we don't want in the first place to include all the things inside of the Git and the Git ignores file also, which are created directly from Angular, and then node modules. We're doing this because we would like the container itself to create those node modules and not to interfere with our local node modules, which we are developing into. We save the file, and now it's time to go to the terminal once again, where we'll be running Docker Compose, and then up this will read our files and we'll build and run a new container. So first we are grabbing the node version. Okay, we're changing into our app working directory. We have already the image for Node. We're copying our packages. So these are the local packages, and inside of the container we are installing our Angular CLI. One thing to notice is that we had one container with our Node image. Afterwards, we removed this container. We're using multi-stage build. This means that in the end, we'll be having a very lighter image of our container running only the Angular web server. Now we see that Angular CLI has been installed also. Okay, so the application is created, and with the copy, we're transferring the application into the app directory, and from then on, we are serving the application. We're creating another container inside. We'll be serving our application. The project is accessible on this port. We are redirecting it to the same port on our local machine. All right, let's see in our browser. Actually, we should see the same content, but this is from within the Angular. We can go in the terminal. We can type docker PS, and we see our container is running. Okay, the next thing is to see whether we can edit the code. We'll go into our TypeScript file, Angular in Docker, inside Docker. Let's go into our browser, but before, let's click on Ctrl+S to save and monitor the output of the container. We see that immediately when we click on save, all those changes have been detected and the container is updated. And so if we go to here and refresh, we see the title is now Angular inside Docker.